Hi everyone. My talk will target an audience of just system administrator or network administrator. I'm not a developer. I believe everyone should understand this talk. Not like the previously with lots of strange language on the screen. Okay, then I'm Olivier Cochard-Labbé. I'm network engineer at Orange, a telco French company. One of my second role in Orange is I'm doing the support for about 300 firewall PF based. On a second job I've got is I'm a visiting lecturer at Rennes University during a few days per year when I give network lesson, but all based on FreeBSD. On my spare time, I am the author of FreeNAS, but I'm no more involved to this project since I've given it to X System. And I'm FreeBSD port committer. On my current playground is a BSD router project, which is just a simple FreeBSD tunes for routing stuff. Then, working on this project, I had to tune it for networking, when I had to build some network performance lab. I reuse the concept of my colleague at Orange, and I try to do it, but just with software and not with very expensive XIA stuff like that. Then, during my talk, I will present you lots of benchmark stuff, benchmark result. And about benchmark, there is a very interesting talk from Brandon Gregg. In his talk, I didn't attend, but I read the slides. There's one slide which says that all benchmarks are wrong. And I'm quite agree with this one, and this will include all my talk too. And I will explain you why. First, before speaking about benchmark and tuning, we need to agree about the unit we will use. I'm a network guy, I'm working with networking stuff. Then the router has two main jobs. The first job is forwarding. It means he needs to forward packets between this interface. The second one is maintaining his routing table with routing protocol, but I will not speak about this. Then our main unit is a packet per second unit, and it's the only unit you have to use when you are a network guy. Second stuff, there is an RFC explaining how to correctly the methodology of benchmarking router. I try to follow, but not perfectly, this RFC, and I will explain you why later. Now that we are agree about the units, you need to understand some reference unit. On a gigabit interface, the maximum line rate is 148 frames per second. We use the term frame because frame is for Ethernet layer and packet just on the IP layer. But in all my bench, I'm using small packets, and one packet is one frame. I will use the term packet per second. On another big detail that it's almost everywhere forgotten, it's gigabit, since gigabit Ethernet, there is two wires. One wire for transmitting and one wire for receiving. It's a full duplex media. Then, theoretically, you need to do transmit and receive at the same time. It means when you are speaking about line rate gigabit router, your device needs to be able to forward at about 3 million packets per second. And this is about line rate router, but on 10 more for a 10 gigabit router. But who needs, technically speaking, line rate? Then I need to introduce you another concept, which is how to translate packet per second with bandwidth. It's quite easy. You just multiply your PPS with the packet size. But on the internet, each packet don't have the same size. Then for simplify, long years ago, they choose a distribution, a standard distribution, which is for one big packet. You've got 4 medium packets and 7 small. This is called a simple Ethernet MX. On using this distribution, from your packet rate, you can estimate or give some value using a standard reference about the equivalent in bandwidth rate. But I'm a network guy. I'm not using the bandwidth at the IP layer. Then I'm using bandwidth at the Ethernet layer. Then I need to add the Ethernet overlay. In my slide, if you will see some table referencing bandwidth, it will be at the Ethernet level. Now, about who needs line rate, gigabit or 10 gigabit router. With these two concepts, packet per second and this distribution, we can estimate what the minimum rate using the simple EMIX distribution for filling your gigabit link or your 10 gigabit link at full duplex. And this is the 7 key, I recall, 700,000 packets per second for a gigabit router, on 7 million for a 10 gigabit router. On my lab, I need that all my devices reach at minimum this value for be called just a simple gigabit router or 10 gigabit. Not line rate, but a simple gigabit. Now, how I did my bench. We are a telco at Orange. We don't sell hardware. Then I need to take care that my customer we don't have any problem. We, as a telco, we don't care about what the customer will do with their link. Then if I install a gigabit router, I need to take care that this router, theoretically, can receive the worst case possible. It's been a line rate traffic using smallest packet size. And this is why my bench are different from the RFC. My bench, I'm generating the worst case ever in one side. On the other side, I'm waiting and I'm measuring what's the rate during this worst case. It's very different of the unit you will see for some material of a manufacturer. Now, on my lab, a little more details on my hardware labs I will use for all my talk. I'm reusing all stuff I get in Orange, and I will do lots of tests. My biggest server is a Xeon 8-core with embedded Emulex card, 10 gigabit card, and the Chelsea card, 10 gigabit. I've got two Supermicro with 8-core Atom, one with Chelsea and one with Intel. This is great because I can compare the behavior between Chelsea and Intel. On two small, one Netgate and one PC Engine IPU. This is for my gigabit world. I don't have Mellanox. I want to test them. They are very good review. I don't have, for the moment, 6-core and 1-socket CPU, and I don't have multi-socket CPU, but this can be interesting too. And about the detail, all the SFP, 10 gigabit SFP are the same everywhere. It's not a matter. Now, before tuning a FreeBSD or every kind of server, there's a first concept that you need to understand, is how today a standard network card is working on a FreeBSD. Today, when your driver loads, the kernel gives the information to the network card how many CPU you've got. And with this information, the network card will create a multiple queue with a maximum value depending on the driver. And then, each time the card will receive a packet, he will use hashing on this packet. On each packet belonging to one flow will end into the same queue each time. It's a very important concept in network world. All packets belonging to one flow need to cross the same path. Then from this first basic concept, now we can have two very important points. And that, like I see when I read the FreeBSD network mailing list, there's lots of problems come from here. The first one is you need multiple flows. If you are using just, for example, Hyper with just one IP source and one destination IP source with the same TCP, it will not work. So you cannot use this correctly. If you are using some stuff like IPsec or GRE, you will break this concept to has endpoint on your router or firewall. You will break this concept too, and lots of people forgot that. As example, in France, I got lots of people using PC Engine's IPU with a pfSense on their home fiber, but the ISP, which is Orange, forced them to use ppwv. And once they did that, they don't have any more multiple flow. They're just using one core, and the performance have a very big impact. This is a very important step you need to understand. The second is what today is a CPU? Is a physical core, logical thread, or what about NUMA? These are some questions I need to answer. Then, for helping you before to try to tune, you need to take care, need to check what's the current queue, how many queues the traffic are spread between all your queue. You've got this information. If you check with SysAtl and FreeBSD, if you get the network statistical information, they are not very easy to parse. Then there is a script from Yandex, which a Python script who allow you to in real time to see how many the queue are. It's very important stuff for a network guy. Then you need to check this step. Once you are sure that you are using multiple flows, we can start to work together. The second step is about what is the core today. Here is an example. Just on my Xeon Hacker with a Chelsea card, when I boot my server in default mode, you see 16 CPU, 8 per 2 thread. The Chelsea, by default driver, choose to create only 16, or maximum of 16 transmit queue, one for each CPU, right? But only 8 receive queue. I don't know why 8, but okay, he chooses to 8. Then here, I say, okay, here is my first bench now. How I'm doing bench? I'm creating 3 configuration sets, one with the default value, a second one where I will force my Chelsea card to use the 16 queue available, CPU available, and the latest one where I just simply disable HyperThreading. My test I'm using, for all my talk, I will use the FreeBSD 11.1 release. Then all my scripts are benched, there's no human interaction. Then I will push a configuration set. I will do a benchmark with pkggen. At the end of the bench, I will reboot again, and I will do it 5 times with a reboot between each time all these benchmarks. It's very important for statistical analysis. At the end, I will have 3 text files for each configuration set. On each these 3 files, I will have 5 values for my file value of my benchmark. And now, a little bit maths. With these 3 configuration files, I'll put them into Ministat. Ministat is a great tool. If you need to do benchmark, it's a mandatory tool to use. It's very mandatory. And he will analyze your different input sets, and he will check if you really have an impact or not. On this example, on the right part, for example, you can see that by default, I've got the worst result. It's on my left side. And you can see with the distribution, okay, there is no arguing about. It's very worst. I reach about 4.6 million packets per second. If I force my card to use a 16 CPU, I've got a little improvement. But if I just disable HyperThreading, I've got the biggest improvement. Then, okay, the first thing is, okay, you need to disable HyperThreading because it does not help you anymore on this case, on this use case, because you've got lots of interrupt, and threading don't help you to manage all this interrupt. The second news, it's a bad news. This device is my biggest device, and I sell to my boss, I will create you a 10 gigabit router. This means 7 million packets per second, and I've got only 5.7. Okay, I need to find a solution. I've got a second question. Once I get this result, was perhaps if I will add some core, a bigger server, I will solve my problem. But before, what's the relationships between the number of queues and of core assigned on the performance on my server? Then I've generated 8 graphic sets. I'm forcing my Chelsea card to use just for the first, just 1 queue and 1 CPU, and up to 8 CPU. And surprise, with a reference blue line, right? It's a linear reference. We've got a problem. I can add CPU, but it will not solve a lot of my problem. There is some stuff, some big difference. It does not scale today. Okay, I'm a simple end user. How on FreeBSD do you dig this kind of problem? It's quite easy. You just need 4 command lines. With this kind of 4 command line, you generate some stuff called flame graph. Flame graph, it's give me the, how to say, the hot function, how they consume their CPU time. And from this graph, I can, okay, I see four interesting points. The first is, there is log contention about the first function, which is called arpresolve. This function is used just for adding the destination MAC address to my packet once they are forwarded. The second one is the routing table. Okay, I've got only 2 static routes on my bench. I try to do some stuff using 8 routes, but no change. But these first 2, as end users, I can do nothing about it. There was a second one called the random harvest queue. I will dig about it later. And the last one is, you see all the part belonging to the Ethernet path, the kernel Ethernet path on the NIC driver. Okay, what can I do? I will try as an end user just to play with a random harvest source. On FreeBSD, as entropy source, by default, interrupt on all Ethernet packet are read. Some data are taken from this packet for using, but at this very high rate, this impacts a little bit your performance. Then I just choose to disable interrupt on Ethernet packet frame from my configuration. It's just with this command line, you change the input, and then I generate a new bench, but in all my server in my lab. And this is the result with all my server. Bad news, on my big one, I've got no difference at all. I've got some improvement with my 8-core Atom, a little bit. On my small gigabit router, see some improvement too. First conclusion here is that I've got 2 small gigabit routers who are correctly able to do gigabit forwarding, from my point of view. The second one is, I still have a big problem regarding my 10 gigabit router. Then how can I do as a simple end user? It's very easy, just call Google, and you will find that these are known problems. They are already fixed since few years by a crazy team from Yandex. They already have patches about that. And I just have to take their patches and to apply it to my FreeBSD. I just backported these patches, one for the 2 log contention. Okay, let's try. Then I keep my harvest mask modified. I apply this patch to my labs. And now here is a new result. Oh, surprise. Almost twice more performance on my router. Which now, okay. My manager will be happy. Second impact is, there is a 10 gigabit NIC into this same server, but it just reached 1.33. It's even not a gigabit line rate. This card, what's this card? Okay. If you dig a little bit, you see that these cards, you can configure the number of queue, you cannot configure flow control. It's a very bad NIC. Then you need really to take care about the NIC card you will use. Shells are very good, Intel too. I didn't have Mellanox for proving it, but there are very, very good reviews about the Mellanox one. Then really try to use good network card. And now with these patches, what about my linear performance rate? I did this bench again, and you can see that the green line is lots more better than previously. Now, perhaps if I can add some core, perhaps I can have more performance. The second one is quite funny because between 4 core and 8 core, there is 6 core, but this does not scale. It's like we need to have a power of 2 number of core. I don't know why, I didn't dig this, but it's a funny value. I was waiting more for my 6 core in this example. Now, how can I try to improve more my performance? I need to work of improving the performance, perhaps, regarding the network card and the drivers of the network cards themselves. Today, drivers are using lots of features. Then I try to look at the main page of the driver. I say, okay, I embed lots of checks and stuff. And there embed two features that are very great for server, for endpoint server, which is called TCP segmentation offload and large receive offload. But these two features are very bad concepts in the routing world. I believe even in the firewall world. Then this is not technical, perhaps technical, but more philosophical choice. I don't want to have these two features enabled in my lab when I try to read the main page. Then I choose to disable this feature in all my lab, and I try to regenerate my bench again for checking if I don't have a performance. Okay, this confirms there's no performance impact at all about this change. Then really on a firewall or router, you should disable these two features. The second one on this slide, you can see that on my 8-core Atom, I've got a quite difference between my Chelsea card and my Intel card, on about 1 million packets per second. Then I try to look a little more how work Intel card, what can I tune about the Intel card. I did lots of tests. There is a long document about interrupt management, about Intel with lots of counters. I'll try lots of things, but like I say, all benchmarks are wrong. On my use case, my bench is very specific with my line rate of packet, and I don't want to impact just my very specific benchmark or not a standard use case. Then I didn't work more on the Intel driver, but at the end, I found just one parameter that matters. This parameter is by default gigabit Intel card or 10 gigabit have a maximum number of packets they process per watt, per time, I need to dig this one. And if you remove this limitation, if you just say, okay, don't keep a high value of the number of packets you can manage in one times, you found a little improvement. And this is, okay, this is only by checking how the user point of view and the driver. This is the only stuff at all I can find. Then I speak about with other, and they say me, but what about queuing, pinning your multiple queue to each CPU? It means you prevent the scheduler to change the CPU of your IRQ. I check the driver, but almost lots of drivers already by default pins the queue to each CPU, with an exception of Chelsea, which is interesting. I'm using Chelsea. There is this function, but it's not by default, and the generic kernel is not enabled. Then, again, Yandex give me a script, I already did all this stuff. And they say, oh, you can perhaps try this script. It's a RC script when you force the binding. I try it. There is not lots of difference. It's just you start to see benefit just with very high throughput, more than 10 million packets per second. For example, on my 8-core, I've got a little benefit, 1%. It's not enough to take care about. On my Atom 8-core, I don't see any difference at all. Since, okay, it's not, for this use case, it's not very important. Then, okay, I believe, just for a routing point of view, I reach, as a simple user, the maximum I can reach. This means, okay, if you want to use FreeBSD as a router, you really need to check the patches from Yandex or from this team. There are online, or there are people.freebsd page, if you know their name. And you need to disable HyperThreading. The harvest.mask need to be fixed too. And there are work in progress in this direction. And if you've got, yes, on TSO, LRO, you can do it. There is no impact on the performance. On Intel card, you can try to play a little bit. Then if I resume just for forwarding, before the tuning on my patch and after, we can find some, okay, a good improvement on the Xeon 8-core with the Celsius, a little less with the other hardware. And this means that, okay, I reach my goal, which is, okay, I've got a Xeon 8 core, which I can call 10 gigabit router. My 8 core Atom don't reach this status. Okay, it's a pity because that cost are very cheap hardware. On my small NetGate, on my small PC Engines APU are great for gigabit routing. This is it's a pretty small, cool machine. But I speak only you about IPv4, but in the range we are doing IPv6. Then let's just, again, Yandex made for me a patches to netmap packaging for adding IPv6 support. I can generate IPv6 packet in place of IPv4. And surprise, ouch, okay. I've got a quite big impact. Hopefully, I'm still over by 7 million packets per second, but the impact is quite, it's quite large. On funny things here, on the shells, on the 8-core Atom, there is no more difference between the Chelsea and the Intel because it's the kernel who lose all your performance on the kernel, not on the perhaps on the driver anymore. Okay, this is the impact with just IPv6. We need to work a little bit on this part. Then, but customers have used standard setup, different than mine. One of these first setup is lots of them are using VLAN tagging. We are using at Orange another setup which I'm calling multi-tenant router, which is using VNET jail. Then I want to check the impact of these two configuration sets on my configuration. For VLAN, I'm just generating, okay, my standard reference config without VLAN, on the second one with VLAN tagging. It's just a very simple difference. On today, the network interface, if you check them, they embed lots of VLAN accelerating stuff. Then, theoretically, they should have no impact with my bench. And, surprise, again, 17% of degradation. Okay, there is a quite large impact on this. But again, it's a known problem. And again, Yandex used already a patch since a long time on their server about this problem. It's regarding the FreeBSD stack. When he got a target frame, he used a long path for de-encapsulating this frame. And once he removes the VLAN tagging, he takes the frame and he sends them back to the beginning of the Ethernet for a standard. It's quite not very efficient. We've got a big impact on here. Then, okay, lots of customers who are using VLAN tagging perhaps will not be happy. But I'm still over my 7 million packets per second. It's still okay. Oof. The second one is my multi-tenant router. I need, for that, by default, you need VIMAGE. It's for the virtual network stack into FreeBSD. It's not enabled by default. Then before to create a new configuration set, I need to add this option in my kernel. Then, if I had to add an option, I bench it. And the result with this option enabled is here. I lose some performance in IPv4 and I win a little on IPv6, but it's very small if you compare to the other bench with VLAN. Then it's okay. It's quite okay. 6% is okay. Now, VNET jail. On my server, I remove all the IP configuration and I move them into a VNET jail. This means there's no more IP address on my hardware, my host. All the IP configuration are into the jail. And I can play now. I play on the PC Engines IPU2. I play to generate, I don't remember, it's between 100 and 150 jails, VNET jail on this small hardware. It's very fun. Then, what's about the impact of this setup? Improvement? Degradation? It's quite no impact at all. It's quite a very, very, very good surprise. VNET now, I tried with firewall, ipfw and PF because it's supported too. It's the same, there's no impact at all. It's quite, once you enable VIMAGE, it's quite a very good news. VNET jail works, really. Okay, now, I'm finished all my forwarding bench. Let's start playing a little bit with firewall. Okay, I will show you a graph after this slide. My first step is just to enable firewall. We have three firewalls in FreeBSD. And I want to check how hard just enabling this firewall impact my performance. The next graph, I will not compare the firewall. It's very important destination. I will just compare how bad they impact my routing firewalling. Then, okay, all bench are wrong. Then don't interpret this benchmark by saying that PF sucks in front of ipfw. It's not what this bench means. It just means that, okay, on my Xeon 8 core, the reference on the left is my forwarding rate at IPv4 and IPv6. And I generated a stateful and stateless setup with a minimum number of rules, 1 or perhaps 2 for IPF, the old one. And I just try, okay, how bad this impact? Bad news, okay, if I want to sell a 10 gigabit firewall to my manager, it starts very bad. Perhaps IPFW in stateless mode, okay. But about all the others, it's the impact. I don't compare firewall, just the impact is quite bad. Now, let's dig a little bit about what is technically speaking a firewall. Let's do a next bench with, in front of my allow all rules, my unique allow rules, I've had lots of denied rules with a non-existing IP in my lab. And I try to play, okay, let's try it with 1, 10, 1,100 rules. You can see still on my, now I switch my hardware. I don't anymore use my big Xeon 8 core. I use my smallest, one of my smallest, it was a Negate. It's a 4-core Atom. Why? Because, like I said, I do a reboot between each my bench. On the reboot on a big HP server takes a very long time, about 5 minutes. On my bench is about 1 minute, and it takes weeks to do all this bench. But the Netgate and IPU are very fast to boot. I'm more interested by the impact and not by the full value. Then here we can see that IPFW and IPF are linear relation between the number of rules and that break their performance. Very, very easy. Then the first rule is you need to keep the minimum number of rules, but very small. At 10, you start to hit your performance, just 10 rules. The second one, it's my PF. What are you doing? You don't care about my rules. Then I dig a little, and these tricky guys convert all my rules into one table. Then all bench are wrong. This is a wrong bench. I'm comparing Apple and Peach because one is using table and not the other one. Okay, you want to play with table. Let's play with table. For this next bench, I remove all my deny rules. I just have one deny table rules and one allow all rules. And I try to increase the number of IP into this table. And okay, using the same feature, we can see that we are agree. Really use table if you can. Really, it's very. The impact is huge. Really huge. Other stuff is a good thing is that PF it's lots smarter by default because he will do that in your place. Then you can save your brain for doing other stuff. Now I play a lot with stateless. So now let's play with stateful setup. On my IPFW stateful, I try to dig a little about the default configuration setup of IPF. And if you check, my packet agent generate only UDP, unidirectional flow. And if from one flow, IPF create one dynamic rules. It's one state on IPFW. If you check this, by default, he accepts a maximum number of 16,000 rules. And you've got, this size is related to the hash table size. It was not very clear in the beginning. When I start this, I discover what is a hash table size. And then I try to increase this hash size tab to the maximum allowed by ipfw, which is 65,000. It's a power of 2. And then I estimate the number of potential keeping the same relationships. Perhaps with this value, I can push my ipfw to manage 4 million UDP flow without any problem. Then let's try. I generate lots of multiple flow by using a large source range or large destination range of my IP packet. And you can see that you can hit, starting at about 10,000, you can hurt a little more your performance. On 1 million, it's totally out of. Then I cannot reach 4 million with ipfw. Okay. Just for information, when I show this diagram to the Yandex team, the next day I had 3 patches, lockless, all the stuff. They're a crazy guy, but okay, I need to do it. I didn't have time to do it for this for today. Now with PF. PF have a different behavior. For one flow, PF consumes 2 states, one for each direction. There is a linear relationships, and PF has the same number of state limit, like PF, on the same hash table size. Then, on my small NetGate device, I've got 8 gigabit of RAM. Then I try to increase lots my hash table for using the maximum value I can, which is about 2.5 gigabit of RAM used for this hash table. And this means about, okay, I can reach 10 million states. Then 5 million of UDP flow in my previous, with my bench. And here is the impact with PF. Okay, he does not care much about the number of states. Then, really, if you want to use a stateful firewall with complex rule, okay, this way, now we perhaps use PF. It's quite a very good behavior for this kind of stuff. Now, let's back. In 2002, when I present for the first time my BSD router project, I complain that we don't have MPLS feature, and as a telco, in a range we are using FreeBSD as a firewall because it's a no-go if you don't have MPLS support. NetMap was existing in 2002, and I was waiting for, okay, where are the software, the user-learned software on FreeBSD using NetMap for routing stuff? Now, today, still no MPLS, but the concept of user space forwarding is a way to go today. If you check today at Orange, for example, preview this solution. When I speak with my network colleague, if I want to install a software router, it were no-go. I cannot talk with them about a software based on Linux or FreeBSD. It's a no-go. But today, they are removing all the Cisco or Juniper stuff, and they are using software router, but based on Linux, because it's a Cisco FDAO and DPDK server. And on this, if you want to compare, then we need to reach 12 million packets per second per core. I didn't even reach this with 8 core. And this is, it's quite a very interesting gap to reach. And this is why when lots of people ask me, hey, can you add to your benchmark? Can you compare it to OpenBSD, or can you compare it to a Linux? I'm not really interested by that. Once, because, like you see, I will never compare a standard non-tuned FreeBSD with another stuff, because it's totally crazy. Then I need to learn how to optimize the OpenBSD and NetBSD and Dragonfly, and I don't have time for that, because you need to compare Apple with Apple. And on second stuff, if I want to add a Linux in my lab, what kind of Linux I will add, what distribution? Then my only interest is, okay, now we've got a value, a reference value to reach. I prefer spend my time to help people to reach this unique value. We will see after. Or FreeBSD, there were from Netgate software called NetMap Forward. I don't think it's maintained anymore. On GitHub, I downloaded it. I didn't reach it to use it. I don't see lots of lots of code updated to it. This is why I'm saying there's no production-ready software on FreeBSD. Well, this is a shame because we are losing a war. Really, it's at last. I'm very happy to see my Cisco or Juniper stuff replaced by software, but it's a Linux. Okay, but all is not lost. If you kernel space forwarding is still improved. Like you say, Yandex have a lot longer list of patch, very interesting. It's an old project called Project Routings, lots of old IDs that we need really to refresh. There were a talk last year about how to improve IP forwarding fast. Interesting talk, because reading this, I discovered that user space forwarding have some problem I was not aware about. Yes, perhaps. Okay, I believe we can still perhaps play this game again. About all my bench script, all the script I've used for all this stuff, all the configuration step I use, all my result, all the flam graph. About when I generate my graph, after I generate a new bench just for generating flam graph. Then for each difference, it can help developer. On lots of the script you can find on the BSD web page or GitHub page are all online. Why? Because I'm very afraid when a FreeBSD developer sends you a patch or asks you, can you test this patch, please? I believe it's improved. I'm very afraid of doing a mistake in my lab or giving false value to a developer. Then this is why I want to lots of more people reading my script or my configuration stuff or my way of doing bench, because it's quite stressful to give false information or bad information. Okay, now, do you have any question? No, great. Oh, that's what you do. Okay.
You were showing a slide where you were comparing like the performances using multiple cores.
Yes.
And if I'm not wrong, when you were using like an odd number of cores, you will have an impact. Is it possible that this is because of the association between cores and the NIC queues? I guess by design you will have an even number of queues. So if you use like an odd number of cores, you will have a mismatch.
Is there a developer who can answer to this question? No? Like, can you bring the microphone? Yeah.
I noticed the very same, and it's actually any power of 2, of course, you employ, it bumps the performance to near linear.
Yeah, but until selling some 6-core CPU, then try to avoid them on your router if you want. This is an advice I can give. But I don't understand this. I need to work with the developer for that. I'm not a developer. Okay. Another question? Oh, you here? No? It's Mr. Netgate. Hello?
First of all, very we're happy to support you. You mentioned NetMap Forward, and you mentioned FIDO's BPP. We basically stopped work on NetMap Forward because we're focusing on FIDO's BPP. There is work underway. The gentleman sitting to my right. It needs about a month to finish. We've been very busy with our.
Then you are working on the user space forwarding using DPDK on FreeBSD? Ooh.
Linux so far, but there is a work of FIDO's BPP underway.
Oh, great. Oh, great. I'm waiting this very... Do you have a schedule? Okay.
At some point, are the Yandex patches going to be merged in the main branch?
What I didn't understand.
Are the Yandex patches going to be merged at some point?
Yes. How the patches from Yandex will be merged? I don't know if it's a Russian culture or not, but they are very. Each time you ask, they say, my patch is not ready, it's not clean enough. They are perfectionist person, you know. Then, because I'm not a developer, my role is to push them and to do some marketing stuff for them, for trying to push this patch. Then yes, I'm using their patch in my BSDRP, I'm testing it on real field, and now I can push them for saying, okay, I can say, okay, I use them, they're working, then you need, I push them to the FreeBSD project, yes.
So, two things. By the way, I wanted to make a comment about what you said about TSO and LRO. For your workload, they should not matter at all, because you should never receive a TCP flow unless it's a control flow. In a router, you never go above the IP layer.
Yes.
So, I'm not surprised they don't have an effect. I mean, they really shouldn't. The only time you'd see an effect is if you were receiving a TCP flow.
Yeah, but
You can turn them off.
But if you don't turn them off, if you keep them, it's a TCO or TCP LRO stuff, the firewall have ipfw, for example, the libalias, the NAT library does not work. Then it's say on the main page, on user have problem with that. Then my advice, if you don't want to have any problem, yes, on the router, disable it. But it's logical. We don't have to use it.
The other thing is on the Yandex patches. Some of them are quite good in a very narrow application.
Yes.
So they will make forwarding better, but they will also have negative effects on the rest of the system, which we have to care about. We being FreeBSD have to care about. The other thing is that what Olivier is looking at is performance, but not always correctness. So the Yandex patches often need a bit of. They're right. They need to be fixed so that they don't just remove locking, they still leave the correct locking.
Yes. Oh, there is another. Oh no, not you.
Well, the next person to ask a question should be like way on the other side. You can give Lars an exercise. So my question was, you briefly touched on the subject of hardware VLAN acceleration and without, but out of curiosity, what is there to accelerate?
Yeah, the problem is when I did my bench, I did a third one by disabling the acceleration stuff, but it's not a correct bench before. We need to fix this VLAN. We need to fix this VLAN problem into the kernel path. And once I will test this patch, I can now generate a new bench without the hardware acceleration for a real point of view about with or without. Currently, because the kernel path already slowed down the rate, you've got a worst result with this feature disabled. But it's not very worse because it's the kernel who already break your performance. Then I will do this. Yes, I will check with the feature and with the feature off. Once I will check the new patch from Yandex. Let's fix this problem.
But I was more interested in like what does the hardware need to do to accelerate VLANs?
Yes, on the VLAN, you had. The number of the VLAN into the packet. On this number, when you receive a target from, then the network have to remove this tag, for example. And this is how to, on just the number of VLAN, you need to remove this tag and use this tag for the virtual interface routing. It's a very small action, really technically, but it's matter.
No more questions?
Oh, here?
Oh.
Okay.
I think you can hear me.
No, you do mine.
Yeah.
Yes, hello.
Hello?
Have you studied any effect of out-of-order delivery of packets?
Of what?
Out of order delivery.
No, I'm using, for the moment, I'm using netmap pktgen, which is a very dumb, very simple tools, just it's a denial of service tools, if you want. If I want to measure out of order packet, I need to have more smarter tools that will read all the an index in each packet generated or will compare. For that, at Orange we've got Xia, which is very expensive hardware, but I don't have it for the moment in my lab. But I need to check, there is a Cisco stuff based on DPD key called T-Rex, and I need to check this software for this kind of more advanced performance test. Yes, really, I need to do it.
Thank you.
Just behind you.
I think like context switching are really impacting in terms of performances, right? You said that there's like a project that wants to move everything in kernel space.
From the kernel space, it's DPDK. It's,
Yeah. Did you make some tests using?
no, because I don't have FreeBSD. Oh, but Jim, perhaps did you already do that? Can you give the micro to?
Just as a point of reference, on i7, 10 core i7, we're doing over 42 million packets a second with BBB and DPDK.
It's quite. Yeah, but we need to fight against this solution on Linux. We need to have the same on FreeBSD.
Hello, thanks for the talk. I just wanted to know about the simplicity of pktgen. And you mentioned Python.
Yes.
It's actually surprising to say, but you can use Python and Python bindings for netmap to give some smartness into netmap. And for example, like for checking of the ordering and stuff like that, multiply that by Cyton, and you will have a decent performance. Try that.
Oh, where did you find this? How do you?
Well, I'm from Intel, and we're doing I'm a network software engineer. I'm the guy who validates those drivers, which you were talking about. And yeah, we do use netmap for different things, like for example, for by the way, flow control testing.
Okay.
And yeah, we use that API to integrate into our Python written tools. And they, well, I thought it would be a huge performance drop when you use Python to manipulate the rings, but wasn't really. It was decent.
Okay.
Very good.
Your script does your script is online or?
No, it's internal open source. That means that it's open source.
Shame on you. Go out, please.
Anyway, here's your sneak peek. Thanks.